Okay, so moving on. As you all know, in today's world, usually the organization's DevOps team is flooded with infrastructure provisioning requests for services that can include everything from virtual machines, servers, containers to multi-tier applications. But do you think this whole process of getting these infrastructure services provisioned is sustainable for a long time? Definitely not, right? Like, because users will need these services in an organized and access controlled manner. So that is where this AWS Service Catalog for self-service infrastructure provisioning comes into the picture. So let us all hear about AWS Catalog and more from our next speakers, Saptak Takalkar and Dharani Saundarya Gopalakrishnan. Saptak is our lead infrastructure consultant who has done his master's in computer science from the University of Texas at Dallas. Besides his passion for best DevOps practices, he also loves to play football. Joining him is Dharani, who is senior infra consultant. She started her career as a developer and then picked up on DevOps and has even played SRE roles for multiple projects and is the anchor for Coimbatore infrastructure community. She enjoys learning sign language, Morse code, and some other interesting stuff like weightlifting as well. So over to you, Saptak and Dharani.
Thank you, Tarushi, for that introduction. I'll quickly share my screen. All right. I hope the presentation is visible.
Yes, Saptak.
Yes.
Okay, cool. Welcome everyone. I hope all the attendees are having a great time and they are taking something out of this amazing event. So in this talk, we will see self-service infrastructure provisioning with AWS Service Catalog. I think we can skip the introduction. I'll directly jump on to today's agenda. So in this talk, we will see why do we need self-service platform. We often call that as a delivery infrastructure platform or a DI platform. What is that DI platform and what the components of that DI platforms are. Then we will see what is AWS Service Catalog, how AWS Service Catalog can help us to build the DI platform. We will see benefits of using AWS Service Catalog, and we will have a demo on the same. Okay. So let's understand evolution of infrastructure provisioning. Back in old days, most of the time, whenever we used to provision the infrastructure or bare metal servers or even the VMs, right? As a stage one of infrastructure provisioning, it was a manual stage, right? But I hope everyone here will agree that it has a lot of disadvantages. And that is the reason why we evolved into the next stage, which is automation, where we started writing everything as code, infrastructure as code, pipeline as code, configuration as code. And this stage or this evolution has definitely helped infra team to cater to a lot of infrastructure requests that are coming their way. Okay, but since the world is moving towards digital era, where these infrastructure teams are also becoming a bottleneck. As Sunit had mentioned in his welcome note that we want a frictionless developer experience, right? So imagine that a very small infrastructure team of that organization is trying to cater to all the user, all the application teams of that organization. And if you think of that, right, and if you have a ticketing system in place, it is not sustainable and it is not scalable as well. And that is the reason why we have to evolve into the next stage, which is self-service delivery infrastructure platform. Sunit gave a very good example, right? Imagine that if AWS has ticketing system, right? Imagine the experience you would have had. It would have been a good experience for you, right? So that's why this self-service delivery infrastructure platform is a need of an hour, where any user, any application team can come to this platform and they can get the required infrastructure provision for their need in a self-served manner. So that's the fundamental of DI platform. Okay. So let's understand what this delivery infrastructure platform is. Okay. So DI platform, as I mentioned, it is a platform which is fully self-service with end-to-end automation. So this will act as the only interface for the user, where user can go and get any infrastructure provision for them, right? And majority of the deployment complexity will be abstracted from them. Even though internally it will be using infrastructure as code, pipeline as code, configuration as code, users won't have to worry about it. They will see this DI platform as a single point of interface. This DI platform can help us to have sensible defaults for all of the products that will be listed on this platform. For example, let's say someone wants to set up an RDS database and they are not aware about the organization's security standards, compliance standards, right? And if they want to have this RDS database provision for their application teams, they can directly go onto this delivery platform and they don't have to worry about these things, because that product will be listed there with some sensible defaults and only the configuration that are allowed to be overridden. Okay. So if you think of this, right, when we create this DI platform, we can think about the organization's ecosystem as well when it comes to the security standards, compliance requirement of that. As I just give an example of RDS, right? Let's say if an organization have a very strict compliance requirement where they want to force SSL for their RDS databases. So when I say force SSL, that means they want encryption at rest, but as well as encryption in transit. So that means whenever any client wants to interact with that database, they have to use SSL for that communication. And those enforcement can be done through this delivery platform. This delivery platform is kind of evolutionary in nature. If you think about doing the lifecycle management of all these products, where you can easily publish new versions of the products or even publish new products very easily. And this platform help us to do a easy onboarding for the application teams as well. As we will see in the demo, we are going to take an example of AWS Service Catalog. Since we are talking about AWS ecosystem, we have IAM as our access and identity management tool, right? So using that, you just have to provide permissions, required permission to the application teams, and that application team can be easily onboarded on this platform. I talked about more about developers, right? That we want to have a frictionless developer experience. Majority of the time, the users of this DI platform will be application teams. But are those the only teams who will use this delivery platform or DI platform? Not really. It should be built to support anyone in the chain of delivery, operations, and support. So we have application teams. As I said, majority of the users of this DI platform will be application teams, but it can be used by the SRE teams as well, who wants to ensure the operational resiliency. It can be used by the security and compliance team, as I had mentioned, right? They can try to ensure that the organization standards when it comes to security and compliance are getting followed. And it can be used by the business leaders as well to ensure that the overall goal of the organization is being met. Okay. I hope we are good so far. Now we will look at the different components of this DI platform. And for that, I will hand it over to my peer, Dharani.
Thank you, Saptak. So we have, when we talk about delivery infrastructure components, right, we might have a thought that, it sounds a little different from what we naturally know, right? So just to give us an example, or real world example, so that we get an understanding of this really well, right? Let's say we all have used Amazon or any of the e-commerce platforms, right? We go to an Amazon app and then we go and buy stuff from there. And let's say I have to buy some kind of a TV. I can either buy individual parts of the TV and then do it as a DIY model, and if you are interested in that stuff, or I can buy a whole TV as well, right? So what do you do when you do that, right? You usually go and search for a product. There are different types of TVs. There is LED based, LCD based. Even if you are someone who likes vintage, you might even go for something like a cathode ray tube based TV, right? So you have the selection of products and usually go for the category, right? It comes under probably some kind of an entertainment category or home and furniture category. And then there will be two workflows in this kind of setup, right? First, the seller who sells this TV goes to the Amazon website. He puts in the information about the TV, and then he just, fixes a price, adds the description and all that. This is from the seller perspective. And let's say from the buyer perspective, we go in, we do a search, and then we decide upon a TV, and then we give an item, we add the item to our cart, and then we do the payment related stuff, and then finally we do a checkout by adding our address. So let's say one more thing that all of this has to follow is someone else should not be able to log in into my account, and unless until I share my password. So they should not be able to log in into my account and then, do all of this. So security is involved. So on comparing that to a delivery infrastructure, right? I'll just give you a quick example. Here, the products would be our, let's say it can be your RDS database, it can be your S3 buckets, or it can be your whole multi-tier web applications as well, right? These are the products that the user would want to create, and it can be categorized into something called as product catalogs. Just like TV comes into maybe an entertainment or home and furniture, the products can be divided into product catalogs, and workflows here simplified as, let's say, seller has a workflow, buyer has a workflow. Similarly, whoever creates these products and then puts them would be a publisher workflow, and then whoever consumes the products. For example, I'm a developer, I want an EC2 for my testing, I am a consumer for this, and that would involve a consumer workflow. And then obviously all of this should follow a secured approach, right? I'm a developer and I should be able to just create EC2s. I should not be allowed to create VPCs or Route 53s, because changing them would involve creating a lot of issues in the existing system. So that should be done by maybe a DevOps person or an infra person or someone who is working on the networking part of it, right? So security is one of the components of the delivery infrastructure. And of course, users are no one but consumers and publishers. So these are the various delivery infrastructure components that we deal with as part of this AWS Service Catalog. So yeah. So what are all the products that I can deploy through this AWS Service Catalog? So I can deploy virtual machines. I can deploy your databases. It can be any of the databases. It can be RDS. It can be a Kubernetes clusters, entire clusters, as well as individual pods inside those clusters, or even small change in those pods that you want to do. For example, increase the replica sets. It can be anything like that. And it can be multi-tier applications. Let's say, take an example of a huge organization, and this huge organization has independent teams working on maybe 10 websites, but all of them at the end would have kind of a similar requirement, right? They would need a front end, a back end, and a database. So let's say instead of 10 DevOps people working on 10 setups, completely different setup, all we have to do is just come up with a self-service delivery infrastructure that gives a multi-tier web application. You just have to pass on a few values, and out comes a fully working multi-tier web application. Of course, the developer has to supply the code, but the background work will all be done by the team. So that can also be done through the service catalog and serverless. The possibilities are endless. You get the gist, right? So instead of each and every DevOps person working on one single thing again and again, and let's say one more team is coming in and they are working on a new thing, we are utilizing the existing resources through the service catalog by making them modular. So what is a product catalog? Like I said, in comparison with the TV, right? A TV can come into entertainment or home and furniture. Similarly, our products can also be categorized into different types. For example, I can categorize my products based on a type. It can be compute, it can be database, it can be your serverless, and it can also be categorized into teams. Let's say there is a data analyst team that should be given just access to maybe Tableau or some UI for their background processes for the data engineering that is happening, and the data engineering team should be given access to maybe your Spark products or EMR or any of that, and by region as well. So depends completely on the logic in which the organization works on. And how does it help? So administration. So instead of let's say I go here and let's say I make a change to some kind of a token that connects to maybe GitHub, instead of me going to Jenkins pipeline, changing it, instead of me going to a different pipeline, instead of me going to 10 different places to change it, in one single place, I get to administer a lot of things. Like I can remove a product. I can make sure that, these people should not be able to access certain number of products because they shouldn't, their role does not not, involve creating or deleting any of them. I can also give a proper access management to all of them. So some people should be able to launch the product, but then they shouldn't be able to terminate it. So kind of like that, security constraints. All of this helps by creating something like a product catalog. So like I said, while buying a TV, there is a buyer workflow and then there is a seller workflow, right? Think of publisher workflow as something like a seller workflow. So you create a product. It can be created using Terraform, IAC. It can be your Groovy pipelines. It can be your any of the requirements that you want to employ upon the product. And once you create the product, you organize them. You put it into some kind of a logical structure. It can belong to certain catalogs, and then you group similar products for ease of search. And then security. Obviously, you have to authenticate and keep some kind of an authentication and authorization and certain access controls for accessing the products. And publishing. Once I'm done with all of this, I publish into publish the product so that the consumer can use it. I can publish it into different AWS accounts, maybe into different cloud, whatever I want. And then finally, I maintain it. Let's say our company has, the company that we are working suddenly goes for an ISO compliance regulation, and they come up with certain number of regulations where, like Saptak said, right, encryption in transit and encryption in rest should be handled. And we do not want to delete the older version of the product. I want to create a new version of the product and put it there. So I should be able to upgrade the existing product. So that kind of maintenance would be done by the publisher. You add, upgrade, delete our products. You do that kind of a life cycle management in this workflow. The next would be the consumer workflow. So consumer workflows, who is using these products? This will be the buyer perspective, right? I want some kind of an RDS or some kind of a KATS product. I go and browse all of the permissible products allowed for my role. And once I have done my search, I go and select the product which needs to be provisioned. And I supply the inputs. For example, I might need a specific version of the product. Let's say I want to deploy a specific Postgre version of the product. I supply whatever parameters is necessary. Maybe I want an EC2 with the 4 or 8 CPU or 12 CPU, completely depends upon our requirement. And once we give the input, we launch that product with the provided parameters. This in turn creates some kind of an infrastructure as a code deployment on the backend. And finally, I manage my side of the product. So once I am done with my work, either I delete the product, or let's say I want to upgrade it to a newer version for my further use cases, then I go ahead and update the product. So this is how the consumer workflow is done. Let's take whatever we discussed in comparison with AWS Service Catalog. So AWS Service Catalog is an offering by AWS that allows us to create, share, and organize all of this that are approved for us. So the advantage of an AWS Service Catalog is that it allows us to do a self-service discovery. In the sense, I can go and search for it and then launch for it. It allows us easy integration with multiple services in AWS. It is also a way for us to do an end-to-end infrastructure automation. It doesn't end when the automation is done. It also helps us in doing a lifecycle management of the products, and it gives us a central point of view. You do not have to go to a Jenkins instance or any of your CI server instance or your local scripts that you're running. Instead, you can have it all centrally managed and then use from there, and then ensure compliance. Like Saptak said, right? There could be some kind of a compliance that your company follows. That says, let's say the company should allow only, the connection should allow only encryption in end-to-end encryption. In that case, instead of, sending a mail or having a compliance tool running in the background, checking for any of the non-compliance related resources, we get to do this at the creation level itself. And also it allows us to abstract the delivery complexity. Like Saptak said, right? We do not have to go and create a ticket and then some overworked DevOps person comes in and then they put their efforts in to create the same product again. So that will not happen in this case. So at its heart, like one other example is that it's just like a menu at a restaurant. So without one, you would not be able to find, and it will also be difficult for the customers to place order, right? So it kind of gives us a menu on what is offered and what we can create. So what are all the components of SC? paralleling the comparison that we just saw with respect to the delivery infrastructure components, almost all of the namings are same, except that in AWS SC, product catalogs are named as portfolios. They also have products, and product catalogs or portfolios, nothing but the category in which the product belongs to, and where we would be able to set certain constraints or any of the rules that we want. And it has workflows, which is the consumer and the publisher workflow that we just discussed, and security constraints. And in this case, security constraints is taken care of by IAM, and users are no one but the users who use these services. So again, drawing a comparison between the publisher workflow that we just saw in the delivery infrastructure platform, in creation of an AWS Service Catalog, you create your products in Terraform or IAC deployment pipelines and use CloudFormation template for input parameters. So through Service Catalog, we need the CloudFormation templates to be uploaded through the Service Catalog, and that is where you get to input your parameters, and you organize the products into portfolios where you group those products. And once you've organized, you use IAM in order to give specific access control and specific constraints. For example, someone should be able to launch, delete, and all of these permissions. As if you worked in IAM, you know it can give fine-grained access control to the person, to the publishers as well as the consumers. And once the security part is done, we publish the products into different accounts and environments, which is kind of similar. And then maintenance, add, upgrade, delete products in their versions. So SC also allows versioning of the products and also allows us to do a lifecycle management. So similarly, drawing a comparison for the SC consumer workflow, we would be able to search for all of the allowed products, and we select the product, we give the inputs through the CloudFormation template. And once we've given the inputs, we can launch the product. And finally, we can manage the provision product. So over to you, Saptak, for the demo. Saptak, you are on mute.
Oh, okay. Sorry, I was on mute. Thank you, Dharani. I guess enough of theory. We will see this in action now. So this is how the AWS Service Catalog homepage looks like. On the left side panel, you will see a section dedicated for the administrator. So this is nothing but our publisher. And using this, we can achieve the publisher workflow. And then on top of the administration, you will see a provisioning section. This is for our consumer users. So that means using this, we can perform a consumer workflow. We will see all this in action now. So before I do that, what I'm going to showcase is we will try to create a product for a RDS Postgres, and we will try to deploy that through Service Catalog. So as you can see, I already have one repository, my Terraform SC RDS demo on code commit. So this repository has a open source Terraform code to provision any RDS engines. And I'll quickly show you the RDS console as well. By the way, I'm in Mumbai region. As you can see, there are no databases created. So what I'm going to do is I'll go to the Service Catalog and I'm going to perform a publisher workflow first, because RDS is the product which I want to list on this Service Catalog so that application teams or consumers can come to the Service Catalog and get that RDS database provision for their application. So for that, I'm going to go in the product list. I will say create a product. Then I'll give some name to it. So let's say I will say Postgres. We will try to create a Postgres RDS database. Owner, I will say Saptak as of now. Then I'm going to use a template file. So this template file is nothing but a CloudFormation template, which we want to use so that users can provide inputs to this product. I'll quickly show you that CloudFormation template as well. So this is how a CloudFormation template can be utilized. As you can see, we are taking few parameters. For example, what would be the database name? Which engine do you want to provision? Version of that engine? On which port you want to expose your databases? Do you want a multi-AZ to be enabled or not? So these are some of the parameters you can expose to the users through CloudFormation template. And as I had mentioned, we can have some sensible defaults. For example, let's say I always want to expose all my databases on 5432 port. So I can have those sensible defaults in my CloudFormation or even in my Terraform code as well. And then in the resources section, as you can see, I have a custom resource, which is actually triggering one Lambda function. As you can see, this is the name of my Lambda function, which is my Terraform SC demo. So what this Lambda function is going to do is it is going to take all these parameters from service catalog, and it will, pass those parameters to this Jenkins pipeline, which is my Terraform SC RDS demo. So this pipeline is our deployment pipeline, which is actually going to run our IC Terraform code. So it will execute some Terraform commands and it will provision the database for us. So I will quickly show you that pipeline as well. So this is our Jenkins pipeline, and this will, I'll quickly log in. My session got timed out. Okay. So this is the pipeline which will get triggered through Lambda. Okay. So I will upload this CFN template now. I will say choose a file, and this is my CloudFormation template, and I will give some version number to it. So let's say this is our first version. Okay. And I will say create a product. As you can see, our product has been created. Now the next part of our publisher workflow is to create a portfolio, so that we can do access management for this product. So we can go to portfolios. I will say create a portfolio. I will give a name, let's say demo, owner, again Saptak, and I will say create. As you can see, our portfolio demo has been created. Now what I will do is I will go inside this and I will say add a product to portfolio, which is the Postgres product which we have just created. Okay. Our product has been added. Now what we want to do is add some security constraint and access management to it. So I will go to the constraints tab and I will say create a constraint. Since we want our consumers to launch this product, I'm going to select that product and I'm going to provide a launch constraint to this product. As you can see the description, it allows you to assign an IAM role to the product that is used to provision this AWS resource, because we want to launch and create this, right? And then since we are inside AWS ecosystem, we will have to select an IAM role. So I already have one launch role created with necessary policies attached to it, and I will select that and I will add it to it. Okay. So we have a launch constraint added for our Postgres product. Now in the access tab here, I will add access management depending upon to what users I want this product to be visible or not. Okay, so for that I will have to grant access to it. For now, I will provide access to, let's say, an admin user. Okay. All right, now even the access has been granted. So any user who has this admin role, they should be able to view this product and provision it. Okay. So this was the publisher workflow. Now let's understand the consumer workflow. Okay. For consumer, what they have to do is they have to come to, again, like AWS Service Catalog home console, and they can select the product. So here, all the products which are permissible for that user will be displayed. As we had just added a permission for this Postgres product for this role, the Postgres product has been displayed here. So I can select this product. And then I will say launch a product. Okay. Unexpected token is not a valid JSON. Okay. Some error. That's okay. We can ignore it for now. So version 1 was the version which we had published. And these are the parameters which has been exposed to our users. I will not change for this demo. I will go ahead with the sensible default. For example, I want 50 gigabytes of storage. I want 13.7 as my Postgres version. The instance type I want is T3.large, etc., etc. Okay, and I'll say launch product. So what this is going to do is, as I had mentioned, it will trigger our Lambda function, which is my Terraform SC demo. And this Lambda function is going to trigger this pipeline. Okay, as you can see, a build has been executed. All right. And in the RDS console, if I do a refresh, you should see in some seconds that the Postgres database has been started. The creation has been started. All right. Now, once the database status becomes available, what will happen is that in the provision product tab, the status will change to available. I don't know why it changed it to available immediately, but ideally it should be available after the database has been actually, available for consumers to consume. Okay. And once the product has been provisioned, there are 3 actions which consumers can perform. One was the create action, which we just saw. Another action which consumers can do is update. So they can select the provision product, and from the actions they can, do a update to this product. And the third action which they can perform is actually terminate the product. All right. So this is a very a small demo, I would say, of Service Catalog, where we tried to create Postgres database through IC code, which we have developed using Terraform. Now we will show you one more workflow of the demo where we will try to deploy some application inside a Kubernetes cluster through Service Catalog. And for that, I will hand it over to Dharani.
Yeah, thanks a lot, Saptak. Okay, I'll go ahead and share my screen. Oh, sorry. Yeah, cool. So if you can see here, we just saw that Saptak create a product for Postgre. Let me show a quick demo of creating an product through Service Catalog and deployment in a Kubernetes cluster that uses Argo in between. So this is a very simple example. I'm going to deploy an Apache web server, and the only thing that I'm going to control is the number of replicas that I'm going to have in the Apache web server for the simplicity of the demo. So if you can see here, the parameters that I'm getting is the replicas and the GitHub project. So if you have worked with Argo, you know that it kind of works on a pull-based approach, right? So when I do any commit to the GitHub repository or any of the repositories that I have connection with, then Argo pulls from it and then deploys it through the Helm chart configuration. So similarly, we have a Helm chart, like if you can see here, my code has a Helm chart for deploying an Apache web server, and I just have a Service Catalog template where I'm controlling the in which the replicas and the number of replicas in which the Apache web server launches. So if you can see here, I am kind of watching the Apache namespace, and as you can see, there are no resources at the moment. And let me quickly create a product just like Saptak showed. So let me go ahead and create a product and then attach it to the portfolio that Saptak just created. So owner could be my name. And for the template file, I have one in my local. I'm just uploading it. And version name can be V1 or any of the versioning that makes sense to you. For now, I leave the rest as empty. So now that I've created a product, I have to attach it to the demo portfolio. In this case, I'm categorizing it into the demo. So I'm adding that Apache to the portfolio. Now, the permissions that are there for the portfolio automatically applies to the product, but then I have to add a constraint for this product. A constraint here means whether I can be able to launch or delete or terminate. For the demo, I'll just choose launch for now, and the select IAM role would be the same IAM role that Saptak used. So if you can see here, I've added the product, and the access is common for all of the products added to this portfolio, which is admin account access, which is the account that I'm using right now. So let me go to the products. Now I should be able to see my product here. Let me choose that and then deploy the product. Let me name it as Apache. And then as part of this, I'm just giving 2 parameters. One of them is my Terraform SA Argo demo. And just for maybe high availability, let's say we give 4 replicas to be created. And I'm going to launch the product. So internally, what happens is that if you've seen the code, it actually calls my Lambda function, my Argo SC demo, where I've written the logic to pull this code and then commit, make the changes based on the parameters that I've supplied, and then push it back to the code commit repository. So for the purpose of this demo, I've enabled manual sync in my Argo, but then you can have an automatic sync, and the automatic happens in 20 to 25 seconds. So in this case, if you can see here, this is the Argo application that I have, and I have created a connection between this and the code commit repository that I just showed. So once the Lambda might have already done the sync, might have already done the commit. Let me do a manual sync now. Yeah, if you can see here, that took the number of replica sets and it was able to create the number of pods here. And if we see here, all of the pods for the Apache web server are in the running state. Let's wait for a couple of seconds before it comes into full running status. And we are just dealing with replica sets here, but we can even deploy the whole applications, the whole Argo applications, or any of the parts of the application, or complete EKS clusters through this process. The process remains the same. Since Lambda is a powerful tool that we can, have some kind of a computing in it in order to create whatever we want. We can do anything we want. We can even create resources in a different cloud or even on-prem by creating accessible permissions to the Lambda. So now that all of the pods are up, let me see if this endpoint is up. I've just created a service for this and exposed it. Yep. So we are this way we can deploy our Argo or our RDS or any of the applications on our backend just from one single location, which is our service catalog. So let me go back to the slides again. So we just now saw the demo for this, and when we launch the product execution flow, we created a CloudFormation template, and this CloudFormation template connected to the Lambda in case of the demo that Saptak showed, right? This in turn connected to Jenkins, and Jenkins was able to launch the Terraform product for us. And finally, it went and created the RDS Postgre for us. So let's say if you want to connect to multiple accounts or environments, you can even, integrate your SNS or SQS in between and connect to different accounts as well from a central account. In the execution flow of the Argo setup, we used the CloudFormation template where we passed the input parameters, which then was parsed by Lambda, committed to a GitHub or any of the repos, and then Argo CD pulled from it, and it was able to deploy the Helm template to whatever cluster we have. It can be your EKS cluster, it can be your GKE, or any environment that you have. And finally, yes, you can also use SNS and SQS if you want to connect to multiple environments from a central account. So I think we are able to understand the benefits from this, right? It allows us to do a self-service discovery and launch. It allows us to give her a security and compliance. I can, go and say, the company can go in and say, I want these products to follow these kind of compliances. All of these products should have necessarily have all of these tags. Then we do not have to have another compliance machine or any of the external software to do this. This approach kind of, overcomes that issue. And fine-grained access control, extensibility and version control. I created V1 right now, maybe in V2, I want to tamper with some more parameters, then I can do and have more versions of what I already have. User satisfaction, of course, we do not have to worry about going through tons and tons of AWS documentation in order to understand it. If let's say I want a database, I just go and supply whatever I want, and in the end, I get a database. You might think, I can go to the AWS console and do it, but let's say in a situation where you want to create a database along with a backend, along with maybe a front end, then all of this can just be done with just a few parameters that we have. And cost reduction, of course, we can avoid having creation of duplication of the resources. We can go into the provision products, we would be able to search the provisioned product, and then we would be able to understand it is already there. That issue is resolved as well. And not only AWS, but there is an offering by GCP called Private Catalog, which does kind of a similar thing, and Azure as well, which has managed applications, which does the same service catalog for their cloud. And obviously, we can use some kind of a compute to connect to other clouds or even on-prem as well. So on summary, The service catalog approach that we discussed helps us to achieve an automated a complete automation, I would say, in doing a self-service infrastructure, delivery infrastructure for product teams, leading to better standardization. And that way we can have a single standard that the company or the organization follows, allows us to do governance from one single place, and helps with maximizing the developer effectiveness. Whereas the developer does not need to spend lots of time in order to understand the system. All they have to do is just go to that service catalog and supply the parameters, and voila, they'd be done. Thank you so much.
All right, there are a couple of questions in Q&A. I'll go ahead and answer it. So the first question is how the user can get the newly created database credentials. So it will depend upon what secret management tool you're using. So let's say if you're using Vault, or if you're using SSM or Secrets Manager, you should be able to store those credentials in that secret management tool, and then you can provide that path to the users. Hope that answers the questions. And the next one is, can we have destroy workflow similar to launch with the service catalog? Yes. As we discussed, there are 3 actions which we can perform on service catalog. One is create, update, and delete. So we can even delete the products which have been provisioned. Okay. If you have any more questions, feel free to put that in Q&A. We will be happy to answer that. Thank you so much, everyone. This has been a very pleasant experience. Thank you so much.
Thank you, folks.
Thank you, Saptak and Dharani. I am definitely going to use some of these insights in my next project, where there are a lot of developers. These kind of things are really great when the developers feel their pain when they need infrastructure, but they cannot because they are really dependent on the infrastructure team to provision those. Such kind of automation would really help in large scale organizations.